All right, everyone, let's go ahead and get started. My name is Tobin Titus. I'm a program manager on the Internet Explorer engineering team, where I focus on performance. I'm also an editor on the W3C Web Performance Working Group. Today's topic is high-performance web platform. I hope that's what you all came for. I know there was a room switch. I'm really excited to see how many people signed up for this talk. I'm really excited to see a lot of people really concerned about perf. Performance traditionally has been somewhat of a niche skill set for a lot of client-side web developers. If you think about the early days of the web, we sort of had our most complex sites could run on low-end desktop systems, and we didn't have to worry about things like power consumption because we're jacked into a wall. But if you looked at yesterday's keynote topic, or keynote from Stephen Elop, it was quite apparent that our landscape's changing very quickly. We have manufacturers who are stretching the limits of our mobile scenarios with these low-end devices. We're also downloading more content than we ever have before, and we're traditionally doing that over mobile networks now. We're also making our pages far more interactive. We're adding a lot more features to the web platform. Yesterday you saw we had WebGL running on some of our phones. And of course, those are adding more challenges that we all have to face. And so that's all great. All these extra features, all this extra functionality is drawing more people to choose the web as the platform for developing apps. So it doesn't really matter whether you're developing an app or whether you're developing a site. Performance is really becoming an essential skill. So it's great to see so many people interested in this. To sort of help with this, over the past couple of years at Build, my team's delivered a couple of talks. One was called 50 Tips and Tricks to Make Your Apps and Sites Faster, and that was 2 years at Build. And that was really just what it says. It was a list of things you could do to improve your site and app performance in HTML and on the web platform. And then last year I gave a talk called Web Runtime Performance. How many of you saw that talk either here or on the site? So I know some of you are gluttons for punishment. Thank you for coming back. And some of you are new here. That's great. Today's topic is actually going to be a level 400 top. We're going to go very deep into some areas. And let's see if I can get this. The agenda is pretty simple, but the topic is going to be very deep. We're going to talk about some of the physical limitations. Like I said, our landscape is changing, and the hardware that we run on really puts more limits on what we can do and how we do it. So we're going to talk about the physical performance limits, and then we're going to talk about the web runtime architecture. Now, I covered that to some degree last year. I'm going to do it again this year just to make sure we're on the same page. And then we're going to walk through a whole bunch of demos with some of the problems and some of the things that you can do and show how those two converge together to create better performance. So we got a lot to go through. My first area is the physics of fast. I love this topic just because it's fun to say, the physics of fast. But it reminds us that hardware plays a really important role in performance. And also, specifically with mobile hardware. So there's a lot of things that limit our ability to execute quickly, to download quickly, etc. Let's just go through some of these. The first are, of course, network utilization and limits. So how fast we can get our content down to the devices that we're actually going to put our content on is limited by a number of factors. And one of those factors that is often cited, especially by cell phone companies, are things like bandwidth. They love to tout things like this. This comes from OpenSignal. And you can see there's various limitations or the various bandwidth speeds for different wireless networks. That's great, but there are diminishing returns on bandwidth after 5 megabits per second. You don't get as much benefit once you go above that. The real problem comes with latency. How many of you are familiar with the latency problem? Great. So Satya touched on this yesterday. He responded to a question about latency. Let's just do a quick demo of this. I'm going to clap my hands, and however many times I clap my hands, you guys go ahead and respond the same. Okay? Maybe not in unison, but that's actually a great a great thing to happen because everyone responded differently. It took different times for different people to respond. And that latency is a good example of that. So if I do it twice, that's great. We've doubled our bandwidth, but the latency is the same. It took just as long for for that round trip to happen, despite the fact of how much data we transmitted. So that's kind of the problem with latency. So it doesn't really matter that bandwidth over a time starts to diminish. We have diminishing returns. The next real limitation we're all very familiar with is speed and responsiveness. And we often think, oh yeah, when you ask somebody who's new to development what performance means, they'll often say fast. It just means fast. And that's true to a certain degree. We've got a CPU utilization up here from a typical page load. And you can see it took us about 1.81 seconds to display this page to the screen. Then we have some animations that are happening afterwards, so you can see a little trailing CPU usage. But it took us about 1.81 seconds to load the page. But that's not what the user felt. The user perceived that the page loaded in about 650 milliseconds because that's our first paintable synchronization point. That's the first point at which we can actually say we have all the content we need to render to the glass. So that's great, but we're clearly not done after 650 milliseconds. We have a lot of work to do. And whatever work we're doing might make the page not responsive. We've loaded it, but the page might not be responsive because it's really busy doing something with JavaScript or something like that. And we tend to measure that with CPU time. So you can look at, in this time, we're actually only utilizing one of the cores of the CPU for about 1.39 milliseconds, or 1.39 seconds. And that's important because we have, in this day and age, especially as we're trying to get faster and faster, we're actually not we're idle for 420 milliseconds on that page load. And that means that we can actually optimize that page. A lot of those gaps that you see up there, it's hard to see because we're just showing CPU utilization, but in a couple of those spots we'll see dips in CPU utilization. And what's really happening there is we've gone completely idle on the UI thread and we're doing some decoding work. So we don't show the different threads that are happening, we just see the CPU utilization. So from a user perspective, we've loaded the page, we're not responsive, and we have to account for those sort of things in performance. The next thing is memory utilization. I love this chart because it looks like the majority of the web is well behaved. And we see this long tail of sites over here off to your, I guess your right. We see a long tail of sites that have a large amount of memory utilization just from graphics. This is a chart of 5,000 sites where we charted how much memory they were using just to decode graphics. And if you live in the state of Missouri, the show me state of all places, I'm really sorry, but a lot of your content is going to be hard to show on a low-end device because you've got 180 megabytes of graphics memory being used just on that site on mo.gov. So it's a really interesting problem that we have. So we have this long tail, but then we also have these other sites. And if you think about it, you say, oh, well, that's great. I'm only using 10 or 20 megabytes. But you forget people have multiple tabs. And what happens when you switch tabs? Okay, well, we have to switch and swap what we're doing with our memory. Well, what happens when you dump your memory off the disk and you keep doing that and you keep doing that? You can actually lower the expected lifetime of a drive from 5 years to 3 years just by not managing your memory properly. And so it's really important that we utilize memory properly. It actually plays a big role, and we'll talk a little bit later where actually your memory bus speed comes into play with your page load. And we'll show that a little later on. Of course, we have power consumption. I have up here, let it rest. When you're done loading your page, do whatever you can to let your page settle down and not do anything, because your users will appreciate it. You often see in a page load, in fact, I'll show this here real quick. We have this page where we're doing a load, and then as we've loaded the page at the end, we can see an XHR request comes in and does an update to the page. This is fantastic because there's a lot going on this graph. At the top, we see our vertical syncs, our V-syncs, we call them. They're just the hardware interrupts from our monitor that tell us we're ready to paint new information to the screen. We actually have a physical limitation from your monitor that says we can only display new information at a certain number of milliseconds. And that's usually your refresh rate. You'll see a refresh rate of 60 hertz. It gives us that magical animation speed that we all go after of 60 frames per second. That's driven by your monitor. That's as fast as we can display new information, a full screen of information to the screen. And what you see up here on the top are our hardware interrupts. And we have this really great optimization inside of Internet Explorer where, if we haven't painted anything new to the GPU, we can put our GPU into a low power state and not process those VSyncs. We can allow it to go into a low power, save the user's battery life, and then wait until we have something new to display. But the problem that we see is a lot of ad networks and a lot of frameworks that people will put in will actually put timers in that'll start doing things like animating an ad or just changing some opacity of something. And the things that happen in the background wouldn't allow us to get the benefit of that power savings. So power is extremely important. It's also extremely important in ways that we would never have dreamed of years ago building websites. You think about a device like your cell phone. It can safely dissipate 5 watts at a time before thermal mitigation starts to kick in. And when thermal mitigation, so you ever have an app running and your phone feels really hot. Well, what's happening is you can safely dissipate those 5 watts, and it's really easy to get to that. You engage the GPU, that's 2 watts. You engage more than one core, that's another 2 watts. You're using an antenna, your Wi-Fi antenna, your cell phone antenna, that's another watt. You're at your 5-watt limit. But it doesn't really matter from a web page if you're just loading content. But what happens if you're an app? What if you build an HTML5 app and you're trying to build a navigation style app where you're downloading new maps constantly, so you're engaging the antenna, you're also engaging the GPS, you're definitely engaging multiple cores because you're decoding those new map images, and then you're clearly updating the GPU with that new map data. If you're running that all the time, you're going to start hitting that thermal mitigation. So what do your customers do? You're in your car, you're trying to drive, you've got this application that you've built, this great application you've built in HTML5, and all of a sudden it's starting to drain their battery. They can see it. What do? They plug it in. I'm in my car, I'll just plug it in so I'm charging. Except that doesn't work. Thermal mitigation says, no, I'm too hot. I'm too hot. So we won't allow you to charge because that creates more heat. So how many of you have stopped using an application when your battery life is low? Exactly. So you start to worry, hey, I've only got a limited amount of battery. I don't want to open that game because it's got ads on there that are constantly moving that will drain my battery life. It's amazing how much ads that move and change will affect your battery life. Power is extremely important. I covered it really thoroughly here because I'll touch on it a little bit throughout, but I want you to understand that power plays a big role in performance. It's not just fast, it's efficient. So what I'm really trying to say is that our targets matter. They matter. And it's not just your devices. I've got devices up here on the screen. It's not just, hey, what devices am I running on, whatever, but it's also you have to think about the scenarios. How's your app going to be used? Where's it going to be used? What are your customers doing? And in what scenarios are they doing those things? So your targets actually matter, and it's important to prioritize those, actually plan for those, and think about it. You don't want to miss out on the opportunities to not run on a low-end device. And you don't want to miss out on the opportunities that those customers are using those low-end devices. So that's the physics of fast. It's important. We're going to talk about the web runtime architecture. Again, I talked about this last year. This is really just how we process content as we have a page load or an app load. We start off on your left with networking. And of course, this is just, we start off making our request for our initial HTML page, and we download that to the client. And then our pre-parsers run through that very quickly and see how fast we can find other resources, sub-resources that we need to download. And of course, we issue new requests for those up to the server and bring those down. That's important because we've got limitations, once again, just from the architecture standpoint. Our contracts basically say that we should limit our connections to 6 connections per server or 8 connections per proxy. I just diagnosed a website the other day that was having performance problems that made 500 network requests in a single page load. If you tried to do those to a single server and you had high latency, just imagine how problematic that would be. So, we've got networking. That's the first part. And of course, we hand that content as that we download it. We hand it off to parsers. And parsers' job is really just to create our internal data structures that we're going to use throughout the rest of the content cycle. And of course, I guess I should advance these. Of course, our one internal data structure is the DOM tree, and that comes from parsing our HTML content. And our HTML content, of course, this is just a hierarchical representation of our markup. It's just a parent-child relationships. And then, of course, we have all of our CSS parsers produce the CSS cascade, a representation of all of our formatting, et cetera, that we have in the page. And then, of course, we have JavaScript. Now, JavaScript is sent down to a sandbox where it's parsed and we create bytecode and native code generation. And there's only really 2 ways for JavaScript to get out of the sandbox. The first is through XHR requests, which again make more requests off through the networking subsystem. And then the other is through DOM API and capabilities. These are ways to manipulate the DOM and the CSS cascade through things like getElementById, appendChild, all the DOM calls that you're used to making. And then, of course, we move off to formatting. Once we have all of our content, once we're parsing all that, we can start formatting what we have. And you can think of formatting as this. We're just taking that DOM tree that we have and our CSS cascade, and we're mapping those together. And we're going to create an internal representation or another internal data structure that's going to represent, all of our formatting. So we don't, the DOM tree doesn't know anything about your z-index or your width or height or any of that. We have to actually add that to those nodes. And then, of course, once we're done with formatting, we go off and we can lay those out to the screen. Now, layout is interesting. CSS is inherently a box-based layout system. So if you see a paragraph on the screen, that's a box. If you see, like an image on the screen, that's a box. And somehow, if you see a circle on the screen, that's also a box to HTML or CSS. And so we lay all those boxes out to the screen based off of your formatting. And we create this display tree. Now, the display tree is everything that we're ready to paint to the screen. Now, I say it's what we're ready to paint to the screen because remember what I said earlier. We have these vSyncs that tell us when we can put new information on the screen. We can't display it yet. We have to wait for the hardware to tell us we're ready to display. It seems like waiting for 16 milliseconds doesn't seem like a really hard thing to do. But in a page load, if you had to wait every 16 milliseconds every time something was updated, it would become extremely slow. So, we have everything in the display tree. Of course, we get a vSync that asks basically that our platform picks up on and says, hey, are we ready to paint new information to the screen? It'll ask layout, and layout will say, yes, I have a new display tree for you. And it'll start painting that off to the screen. Now, of course, that's where we move off to painting, where we paint all of our surfaces. In Internet Explorer on Windows, those are DirectX surfaces. So congratulations, everyone. You may or may not know you're actually DirectX developers at this point. So you're painting off to these surfaces, these DirectX surfaces, and then we hand it off to the GPU to composite. This is where the hardware acceleration comes into play, where we're actually just taking all of our surfaces, telling the GPU to handle it. Now, if you have a device, if you have a Windows phone, you have something like that, go ahead and take that out and just go to, there's a new site we announced called status.modern.ie that just talks about all the new stuff that we have. Because I'm going to talk about input next. And input, we tend to think about as backwards. And I want you guys to see this come into play. You can actually go to any website that you want to. If you're already on one, you're doing some tweeting or something like that on a website, then go ahead and we can walk through a sample here. But we tend to think about input as coming in backwards through the pipeline. And that's because what we do is we actually allow you to manipulate. You'll see dmanip listed up there. That's called direct manipulation. You can actually manipulate what's directly on the GPU just by touching your screen. So if you pinch into your page where there's some text and you zoom in, don't let go, you can actually see the aliasing happening there. Because what we've done, we've already painted our surfaces, we've handed them off to the GPU, we've got a bitmap that we're actually manipulating there. And then when you release, you can see that we repaint and recomposite. So you can actually see that coming into play, and we're going backwards. That allows us to not block the UI thread while we're manipulating our content. So that's the web platform architecture. That's how we tend to think about it. It's how we tend to think about content. This comes into play no matter what you're doing. You know, if you think about how pages are loaded, this may not all happen in one direct order. We may have new content constantly coming in, and we're formatting it, and we're laying that out while we're also finishing up an animation. Or we may have a new animation preparing the new one. So we're going to constantly hit this loop of formatting, layout, display, JavaScript, formatting, layout, display, JavaScript, and we're going to do that as often as we possibly can. We'll touch on efficient ways to do that in a minute. But how we display and how we determine, at least on Windows, how we're hitting all of those subsystems, we actually have something called event tracing for Windows. And this is just a lightweight logging mechanism provided by Windows that gives us a whole bunch of rich data about what's happening in the web platform. So we can see what's happening from download to formatting to layout to display. We can see exactly what's happening in amazing ways. We also go so far as to allow you to sample the CPU. So apart from having these attributed logging events, we also allow you to see and sample the CPU and interrogate it and ask, hey, what are you doing? It's kind of annoying. It's kind of like the trip you're on asking the parents, are we there yet, are we there yet, are we there yet? It does have some performance implications, just like asking your parents, are we there yet? But, you know, but in general, it's very lightweight. It's not too much of a problem. And of course, once you're done taking a trace, it's written out to a file where we can analyze it. Now we've got two ways to look at those ETW events. You can write your own providers and your own consumers for ETW, but we've got a couple for you. Of course, we got one in F12 developer tools that we released for IE11 in the HTML UI responsiveness. How many of you guys have used that tool? UI responsiveness. Okay. So in the F12 tools, we actually have this in the top here. We see our CPU utilization. It allows you to see a breakdown of what's happening inside of those subsystems. So you'll see things like display, I think they have up there. Yeah, so the loading would be like your networking and your parsing and all that. And you can actually break down and see the waterfall of exactly what's happening inside of those as well. So this is just a nice timeline chart. And of course, we have the Windows Performance Toolkit that also gives you some great insight. This is a different view than what you see above, which this is all of the different threads that are executing. So above, you can see what's happening on the UI thread. And down here, you can see all the other threads that come into play as well. So it's a great set of tools that we can use. Now, I'm not going to go and cover these really in depth this year. I covered them very deeply last year. We also have another presentation tomorrow from Lalithra. He's in the audience here somewhere. I saw him in the back. He's giving a talk tomorrow at, I think, 2, something at 2 o'clock. But in any case, check it out. It's measuring performance on Windows and Windows Phone. And it's a great talk. It's another level 400 talk. If you want to know in depth how to measure performance in the Windows Performance Toolkit, it's a great talk to go to. So we've talked about all of the physical limitations. We've talked about the web runtime architecture. Let's talk about how those things come into play and affect your performance. So we're going to walk through a whole bunch of really cool, a few back and forths between slides and demo here to cover. So the first thing we're going to talk about is network optimization. And this is just about getting content to your user. This is networking, or I should say navigation timing. And this is all about, you know, all of the events that happen, all of the things that tell us what's happening, at least in a page load. And, you know, this information is available. If you go to your F12 tools, you can actually just pull up the console and type window.performance.timing and pull up all of this information and see exactly what your timing was. And if you look at this chart, you can almost look at your opportunities to improve performance. You can see, for instance, if you have limited DNS, if you've only got a couple of hosts that you're hitting, then you limit the amount of times you have to actually resolve your DNS. If you you connect to a single server, of course, you've got this TCP. You don't have to make a ton of connections. So the more simple your page is, the better you can be. There's a lot of stuff that happens here, and you can actually just almost see it in the chart where you can make optimizations in network and in navigation. From HTTP Archive, if you don't know Steve Souders, you should. You should read his books, great books. It'll cover a lot of the same information to one degree or another. But there's some of this information from HTTP Archive as well that gives us an average payload for a site. 93 resources on average are downloaded. That's pretty significant. We're doing that over 16 hosts. Remember what I said earlier about having this sort of connection limit of six resources per host? Well, we're almost at that if you take 93 divided by 16. And believe me, these are not evenly distributed across domains. So we're definitely hitting these limits in places where we have to wait because we're waiting for a connection to open before we can go get our next piece of content. The most significant of all this content is images. So as you can imagine, your images play a significant role in how performant your site is. And that's only reinforced when you start looking at the size of the content that we download. 1.7 megabytes per page. And again, we're doing this over mobile networks with people who have limited bandwidth connection or limited download per month on their limited data plans. And only 46% of what's on the web is cacheable. For one reason or another, more than half of the content out there is still not cacheable. So it's important to remember that as well. But once again, look what's taking up the majority of our downloads. It's images. So I'm going to spend a lot of time talking about images, and that's where I'm going to go very deep, talking about how to optimize images. And we'll show you how much of a difference you can make with just images. So let's take a look at a couple demos. Great. So the first one is just about right-sizing your images. Something that's very common, especially as you have responsive design, and has really been happening. We see it a lot in applications as well. Is where someone will bring down an image, a very large image, high-resolution image, and they'll simply scale it down to the size they need to display it, depending on the device. That's great. But remember, that image is being downloaded. The entire image has to be downloaded regardless of the device size. And so you're wasting a lot of bandwidth. And let's just take a look at some of the differences here. So I'm going to click on this. These are large images scaled down. I built this little site. You can see that at the end that laptop image popped in. Everything else had loaded, but the laptop image popped in last. And that's because what's happening is that there's a ton of images on the site. If you scroll down, you'll see there's just a whole bunch of little images that we added to the page. And every one of them is bigger than they're actually displayed to the screen. Now, if we look at this again on images that are right sized, you can see it was very quick and speedy. And everything was displayed rather quickly. Just to kind of see how much of a difference that is, you can look at the results here. You can actually see the difference. We have a 1.8 second page load versus a 625 millisecond page load. And again, if you look at the top, you can see all this blue that's happening. That's CPU utilization that's being used to decode all of those really large images. And again, wasting your battery life because you're having to actually use the CPU to decode all of that. And then if you look at the tiny blue section that's over here, you can see that we're actually decoding far less. So does everyone get that? Does everybody understand that? Good. So the next thing is reducing the number of downloads. So we talked about the average page having 93 resources that we download. Now, I've only got about 30 on this one, but here I'm going to go ahead and click download individual files. And that one's kind of hard to see over this. I've actually got a really nice wired connection here, but it's kind of hard to see the differences between these. And here I've sprited and minified everything. Now this is kind of an interesting one because and I do this on purpose, but you'll notice that the center headline popped in. And it took a while to pop in. It's because I sprited all the headlines, and this is actually, just a carousel, and all of these are just one big image. And I just wanted to point out that we see this a lot where some of your most important resources at the top probably shouldn't be sprited together with a whole bunch of other large images because it'll give you that popping experience as well. So let's just take a look at the differences between these. And again, these results all came from me connecting in Redmond to a Redmond-based server. So the further away you are, the more pronounced this can be. And here, this doesn't seem like much of a difference. You've got 210 milliseconds versus 164. It's a minimal perception. But remember what I said. I said I've got 30 resources as opposed to the 93 that are on average. So we start to see pretty significant differences when we start to add those up. And then last but not least, I have this using a CDN. So remember I said, we have this connection limit. We can only connect and download so many resources per host at a time. So using a CDN is a great way to say, I'm going to use multiple hosts, I can make multiple connections, I can get things down much faster. So here I have an example of the same site without a CDN. It's all connecting off of one site. We've seen that before, and now we're going to use with a CDN. And once again, the demo gods are giving me a conflicting experience. But if you look at the differences that you can see, keep in mind, I guess our differences was one is hosted in Redmond and one is hosted in New York. And so up at the top, we can see, hitting the East Coast without a CDN. It's 1.3 seconds to load the page, versus the difference here of about 656 milliseconds. So you're saving about half of your time just by using a CDN in this scenario. So I'm going to pop back over to slides real quick and talk about a few more things before we move on to our next demos. Speed and responsiveness. You have to make effective use of your CPU and your graphics card to have great performance. So here I have a tale of two news sites. These are actually from actual news sites. I won't name them. I don't want to embarrass anyone. But this is a page load for one of those. 35 seconds to load the page. And you'll notice at some points we have the GPU that can't do anything. We can't display anything. We're just blocked. There's a ton of scripting time in there. You can see there's a ton of idle time in there as well. And so this is just a page load that's constantly adding things. I think there was 3 Facebook like buttons on this page, and none of them had the same numbers, and they all came from different sites. There was like the same thing with Twitter and et cetera. So there was a ton of these little extra graphics all over the place, and it was just slowing down the page. And then I had another site that I hit, 4.5 seconds. Same article, same AP source. But that's just the difference in how they used and what they decided to choose. And so there's a number of things. There are just a ton of things that we can do. And again, I would refer you to one of our talks of 50 tips and tricks, but there's a ton of things you can do to reduce your CPU time. And we're going to show you a few of those demos. So the first one is really about deferring script execution. We still see, surprisingly, a large number of sites that are putting script in the heads of their pages. So if you put your script up at the top of your page, what happens? Well, we don't know what your script's going to do. We have to actually go through and interpret that script or compile that script to know. And if you're going to do a document.write or something like that, we can't move forward until we know that. So by contract, we have to execute that script before we move forward unless you've marked it as async or deferred or something like that. So this is what happens when you put a ton of scripts. Now this is going to be a different demo. It's the demo I showed you last year with animations. And it was just a page that you load, and there's a whole bunch of animating logos on the page. And you can see we're at 60 frames per second, so we're not really limited there. But what we are limited in is the page load time, because what I did is I took the scripts for that page and put them at the top. And in the next one, I actually put them at the bottom. And again, the perception here is hard to tell on a small site like this. But when you start to look at this, it's 438 milliseconds versus 84. You can see I have 25 frames into my animation on the bottom here by putting my scripts at the bottom before I instead of putting them at the top. And that's because what's happening here, you can actually see at the top, we have to wait to download this. Now, I cheated a little, just a little. I took a trace here, and this one just happened to be great because the latency and everything else that we had took a long time to get to that script that was at the top of the page. But remember what I said, we can't move forward until we have that script because we've run across it. We have to execute that there. So we have to wait for it to download. And it's downloaded, and then we can execute it and then move forward. But if you move those to the end, you move your unimportant scripts in particular to the end of the page, then you don't have to worry about that wait time. You don't have to worry about anything that might happen from a network standpoint and delay your page load because you have to wait on a script that's not that important to the page load. So the point is defer script execution as much as possible. Reducing the number of frameworks. This one's fun. You can see that took quite a while to come up. And then, of course, we have a single framework that was really quick. And it just popped up. And what happens is, you'd be surprised. Start just looking at the source for pages that you go to that are slow. You'd be surprised how many of them have just a ton of frameworks in their page. And they're usually only using them for one small feature. Either it's selection with jQuery, or it's just doing it like just for layout with Bootstrap. And then they start adding a whole bunch of them thinking they might use that framework at some point, and then they never do. And then it's just dead code waiting there. Like I said, it's amazing how many sites we look at that still have a ton of frameworks. So let's just look at the difference here. All that yellow you see in there is a lot of garbage collection as well. So when you have all these frameworks, you start doing things. You have to start throwing things away. So we can start to see, we're fine. We load our page off to your left, and then we're several frames into our animation, well before the other page loads. Oops. So our next one is coalescing style and layout changes. So, if we this one's a little bit harder to follow, but we'll stick with me for a minute. I've added one of these nice Facebook and Twitter and LinkedIn things off to your left. And you can see it's one of those little social bookmarks. It's going to follow me as I scroll down the page. And you can see how jittery it is. Just very jittery as I go back down the page. It's because I'm processing an update to relay out that particular element on every mouse event, which happens to be much faster than we can actually display to the screen. So we're getting a high resolution mouse input, and we're getting the lower resolution display. Now what I did here is that on this one, I'm actually just updating the layout on RAF, and just for an extra little smoothness, I'm also using CSS to transition it into place. So we can see it just fly into place. And it's actually much cleaner if you look again at the results. This is just a scroll event. You can see this is the animations that are happening. At the top, you can see we have multiple scroll events that are happening in between our actual animations. And those are basically wasted. We can't do anything with that. We can't actually display that to the screen. And on the bottom, we're actually just coalescing all that together. It just gives us a cleaner experience. And then last is just talking about using CSS animations when you possibly can for dependent versus independent animations. What I have here is just a JavaScript animation, just a rotating box. It was just a simple example to come up with. But then, of course, we can go back and look at an independent animation. It's doing the exact same thing, no difference, indistinguishable. But let's look at what happens when the difference in the CPU and GPU utilization. What I have, this is coming from the two results from WPA. And so you see at the top, we have our vSyncs that I talked about that are telling us, hey, we can display new information to the page. And then there we have our CPU utilization that's executing our updates. And then, of course, our GPU utilization. And that's for the top. But what happens down here, what happens down here on the bottom with independent animation? You can see the Internet Explorer actually isn't doing anything on the UI thread. All of that's happening in animation on the GPU, in DWM. All that's happening there. We don't have to do anything in Internet Explorer to sync that animation up. You can also see that the GPU is doing a little less work. Every little bit counts. Remember what I said about power and how important it is. Every little bit helps. So that's speed and responsiveness. See how much time we have? Okay, great. Let's switch back over real quick and talk about memory. So again, I talked about how important memory was, and so we're going to spend a significant amount of time talking about images. So again, we talked about download sizes. Those are kind of important, but download sizes and the memory size, the size of memory, are much different. So we have this image up on screen. It's actually a pretty big image at 557K. If you remember back to our average payload, that's about half of the average payload of images for a page. So 557K, it's a nice, big, high-resolution image you want to display to someone. So you think, great, that's all I'm using. It's not too bad even for a low-end device. But to figure out the memory, generally speaking, you can multiply width times height of that image times 4. And we're using 2.67 megabytes after decoding just for that image. It's a pretty significant difference. And of course, I'm going to talk through this image decoding process because it's important to understand what happens here and some of the things that you can do to improve your image utilization on pages. So we have, of course, our network request that comes down, and we get a partial response. The important thing is here, we don't have to have the full image down before we can start decoding it. You saw that on some of our demos where some of the image would come in and it would display part of it, and then we would display the rest as the image came in. So we'll get a partial response, we'll decode that. We'll get the rest of our response, we'll start decoding that, and of course we can finish that off. Then we move off to processing. There's some processing that happens afterward, and we'll talk about what that specifically is, but it's a lot of image conversion or color conversion that happens. And then of course we have to copy it over to the GPU. And then finally we display it. So that's just the basics here, and you can see this I put up a single page that just had an HTML page with a style sheet with a background image. And it was a large background image because I wanted to actually see what happens here. But you can see that on the bottom here we have the UI thread, and we're doing all of our work to download and do parsing. The green is our decode thread. So you can actually see we download part of the image, we start doing some decode, we download the rest of our image, we finish off decode just like we see above. And then of course our GPU here, we can see that after we finished doing some of our decode, we displayed some to the GPU on the bottom. And then when we finally finished, we did the rest of our display to the screen with that image. But what's happening here? There's a big lag between finishing decode and that GPU. That's the copy. That's how long it took to copy that over. And this is over a low-end device. Remember, your devices can have as low as a 6 megabyte per second memory bus. So that image that I talked about that was 2.67 megabytes, nearly 3 megabytes, how long does that take to copy over? About a half a second. So your page load is actually affected by your memory bus speeds if your graphics intense. So it's really important that you use the right images, which brings me to my next point. Image formats matter. You can look here at a typical RGB image, RGB-based image. You can see in each of our channels, the red, green, and blue, we have a lot of detail in there. And that detail, we actually have to process. We have to bring those together to create that great little image of the Grand Tetons that you see over there on the left. But this is YUV. We can actually see our Luma channel and our two Chroma channels. There's not as much detail in those other two channels, which means we can compress those. And as it turns out, we're not as sensitive to differences in those two channels as we are in the detail image. So we can compress those and still get the point of the image. So these two are different. At the top, of course, these are your pings and your GIFs, and at the bottom are your JPEGs. And this is what happens when we encode and save. When we encode our image, when we say, okay, save this as JPEG, what's happening is we're converting from RGB to YUV, and then we're doing our chroma upsampling, which is what I'm saying, we're compressing those two channels. If you want to know really, really deep on this, there's another talk that Frank Olivier from the graphics team is giving tomorrow. It's fantastic. He goes even deeper on this. But we do some chroma subsampling, and then, of course, we finish encoding the image. When we download and decode the image, we're doing that backwards. So you think about it, we're doing our decode, then we're doing chroma upsampling, and then, of course, to try it, because we've compressed those two channels, and then we're converting again from YUV to RGB. So this is that same image that we talked about before, and I've kind of highlighted in colors what you can see, the decoding and the processing, because we're going to break that out in a second. This is IE10 processing a JPEG. This is what IE10 did, exactly what we talked about before. But in IE11, we've actually optimized that. As it turns out, GPUs can process YUV. So we don't have to do that color conversion on the CPU. We can actually do that on the GPU, where resources are a lot more plentiful. As it turns out as well, we have a little less decoding work to do. Overall, this can actually save you 40% CPU utilization and around 30% memory utilization by using JPEG. We've seen a lot of CDNs. I talked about using CDNs. We've seen a lot of CDNs that are actually converting over to converting their images on the fly over to JPEG or a JPEG variant, simply because they actually save people both download as well as CPU and GPU utilization. So your image formats matter. Let's take a look at some demos on this. All right. So here we have some large images. This is, again, I'm going to go back to the right size image thing, because I want to show you that first. But these are large images, and we showed that before, and then we showed the right size images, and of course the difference there. I've got these cached now, so it's not going to make as much of a difference. But the results that you can see from a memory utilization standpoint are pretty significant. 66 megabytes versus 37 megabytes. And that's the difference just between images. And that's the difference in choosing right size images versus scaling your images. And again, on a low-cost device, if you want your app, you're building a great app, you want it to work well on a low-end device, then you're going to need to make sure that you use those resources as wisely as possible. And then, of course, I want to show you the JPEG. So this is ping. These are all just ping images. Everything on the screen here has been, pings. And then, of course, we've got JPEG. You can see the page loaded a little faster, and the results look very similar. And here's the difference. Just by switching to JPEG, the memory utilization goes from 51 down to 45. And again, remember, I've got half the resources that half to a third of the resources that a typical average page load has. So as you start building your applications, these things start to really come into play. So that's really that's my talk. Like I said, we've got a couple other talks on performance. We've got one that's really covering graphics in depth. It's the PM for WebGL. as well as a couple of devs that we have here that will be doing a talk on graphics. I highly recommend you go check those out. In the meantime, just start thinking about this. We want to reach out. The reason device manufacturers are building low-end devices are not simply because they're trying to save money. It's because customers are trying to save money. They want that smartphone. They just don't want to pay a lot for it. I remember, I dare say this because it'll date me, but I remember a commercial when I was a kid, from Meineke. Said, I don't want to pay a lot for this muffler. And that was just like some angry guy saying that. But it's the same thing. People are like, I want a smartphone. I want to be able to do things on it. I realize I'm not going to get the top end, but I just want to be able to do things on it. They've got a lot of customers asking for them or they wouldn't build them. And so if you want your applications and your sites to run on those devices, you have to start thinking about everything. And memory, for me, I concentrated a lot on graphics and a lot on memory. Of course, you could do the same thing with that list of 50 tips and tricks. And as you start to go through them all and measure every little difference, if you take a typical site like that 35 or 33 second long page load, and you apply all those practices and measure the difference, they're dramatic. So that's my talk. If you have questions, I'm willing to take a few. Yeah, so I mentioned Steve Souders' book. He has a great book on, I think it's high performance websites. Ilya from Google has a great book on from networks, and he covers this stuff in more depth than you could ever want, but it's really important stuff. There's, of course, a couple of talks that we've done at Build, the past talks, the 50 tips and tricks that we talked about. And then the measurement. We've got talks by Lilithra tomorrow, the graphics ones. So these are all great books. I'd highly recommend you start looking at those. Anything else? I'm sorry?
Or the results you're getting from each request that you had on your demo.
Yes.
What were you using to sort of?
So the question is, what was I using to surface those results from my demos? So by and large, I use mostly the F12 tools, just the F12 in-browser tools from IE, but you can use WPA as well. Yes? I'm sorry, say that again? Uh-huh. Talk to me afterwards. I'd love to understand what more about what you're trying to optimize for, and go from there. Yes.
Are we looking at any WebP or any new formats for compression?
Image formats are, I hesitate to say they're a little interesting. Everyone wants to put out their own formats. They're largely JPEG variants for the same thing. They're trying to save in the same areas. Trying to get everyone to pick the same ones and do the same ones or agree which one's better just really comes down to the same problem we see here. Because performance is a lot of, well, it depends. It's trade-offs. And so each one of those formats have different trade-offs, and different browsers are optimizing around those formats. So in some ways, it's a good thing that there's multiple formats and there's different ways to do it, and that each browser optimizes around their own formats. In another way, it's really hard because adoption is low. So looking at JPEG XR, JPEG 2000, WebP, all these is like, well, again, we're going back almost to browser sniffing to figure out which one we should support. It's a good question. I don't know that I'm going to be able to answer it today. Hey.
Is there a benefit to serving JPEG XR to iOS?
Yeah, most definitely. There's definitely memory optimizations, and of course, just like anything else, they're packed a little bit better. So there's definitely. The question was, are there benefits to serving JPEG XR and IE11? And yeah, there are definitely performance improvements there. Yes.
I was wondering about lossless optimization of images, where you remove the metadata.
Let me say that again.
Where you remove the metadata of images, like what camera was used to take the JPEG and everything. Have you seen any reasons not to do it? how to do that?
I don't know that there's going to be a lot of performance benefit to removing the metadata out of that. I mean, if you're trying to eke every little bit of performance out of that, yeah, there is. I mean, it's basically, data that you're more data you're transferring. So if that's what you're like, it's just more data. So if you're trying to improve every little bit of network optimization you can, and that's fine. Typically the first thing that happens when an image comes down is we look for the metadata that we can parse, and we're really just looking for the width and the height to see if it can give us some clues, some early clues as to what's happening, and how we should decode that image. But yeah, you're not gonna. I don't think you're going to save a whole lot from that. The beautiful thing is you've got the tools available to you. You can actually play with that yourself and figure out, if there's a difference that's worthwhile for you. Yes? I'm sorry, can you say that again? Yeah, so there's some great tips and tricks around. The question is there any benefit to generating on the client side versus returning on the server side? Clearly, whatever you can return, again, it goes back to what I said earlier. It depends. How much are you returning? How much do you want to show to the user up front, and how much do you want to build on the back end? How much do you want to just reserve and wait for them to slow down? You look at a lot of sites that are doing the automatically, as you scroll down, they'll add more content. In a way, that's great because you're saving on the network. You're not having to render a really long page or lay a really long page out. You're just laying out what you have to for the initial page. And you let the user dictate how much more they want to see or how often you download it. So yeah, it just depends. If you were to take the news site that I had today and just pop up a white page and then start dynamically generating elements, it's clearly going to be slower than just rendering back the markup. So yeah. Anything else? Okay, great. Thank you guys so much for coming. Appreciate it.